Now we can review the gradient, divergence, and curl operations in cylindrical coordinates. So let's start with the position vector written in Cartesian coordinates. It's x I hat plus y j hat plus z k hat. Now x coordinate transformations from cylindrical coordinates. There we have the coordinates rho, phi, and z. X is given by rho cosine of phi, in I hat direction. And then we have y, which is rho sine phi in j hat direction. And then for z, we have z. It's the same thing in cylindrical coordinate system. Now I have to look at the scale factors. So I take a derivative with respect to rho of the position vector and take its magnitude. So I have for the derivative cosine phi I hat and sine phi j hat. So I have the magnitude of cosine phi I hat and plus sine phi j hat. So the magnitude gives us square root of sine square plus cosine square. So we have sine square phi plus cosine square phi, and we're taking the square root to find the magnitude, and this gives us 1 because sine square plus cosine square is 1. As for the second scale factor, h phi, I have to take a derivative with respect to phi. The derivative with respect to phi gives me minus rho sine phi and plus rho cosine phi. So I have to look at the magnitude of minus rho sine phi in I hat direction plus rho cosine phi in j hat direction. And this is going to give me rho times square root of sine square phi plus cosine square phi which is 1. So this is rho times 1, which is rho. And as for the third scale factor, it's actually the magnitude of k hat, which is equal to 1. So we're going to get, for the gradient operator, qi hat over hi del qi, applied to a scalar function phi, I have del phi del rho in q rho hat direction because the scale factor was 1. As for phi, I have 1 over the scale factor, which is 1 over rho del phi which will give me the component in q phi hat direction. And for the z component, I have del phi del z in qz hat direction. So that takes care of the gradient operation. As for the divergence, I have 1 over hj hk del k qi hj hk ai. So I have to substitute for the product of the three scale factors here. I have 1 over rho. And then I have del hj hk. So this is going to be rho a rho with respect to rho, derivative with respect to rho. And then I have again plus 1 over rho. As for phi, I have, because the scale factor for phi was rho, I don't need to consider that. So I have only del A phi, del phi. And for the z part, I have plus 1 over rho del rho az del z. All right. So we can put it together. So what we have at the end for the divergence is 1 over rho del rho a rho del rho plus 1 over rho del a phi del phi and for the z part we have also 1 over rho del az del z. So this is going to give us the divergence. As for the curl, we can calculate it using this determinant 1 over h1, h2, h3. h1, q1 had h2, q2 had h3, q3 had first row, del del q1, del del q2, del del q3 second row, h1, a1, h2, a2, h3, a3 third row. So 1 over h1, h2, h3 in this case is going to be 1 over rho. Then we have the determinant q rho hat, rho q phi hat, and then we have q z hat. Del del rho, del del phi, and del del z. And then we have h1 a1, which is a rho, h2 a2 rho a phi, and then we have h3 a3, which is a z. So if I take this determinant with respect to the first row, plus minus plus, this is going to give me the following result. For the q rho hat part, I have del az del phi minus del del z of rho a phi. That's multiplied by 1 over rho. So the first term is 1 over rho del az del phi minus del rho a phi del z, which is this part, this is in q rho hat direction. Then I have minus rho q phi hat. Rho and 1 over rho will cancel, so I will have minus sign here. So I'm crossing the first row and second column, del az del rho, del az del rho, and then I have minus del del z a rho. Minus del a rho del z in q phi hat direction. And for the last part, first row, third column are crossed out. So I have 1 over rho plus 1 over rho. Now I have the derivative with respect to rho of rho a phi. So del rho a phi del rho minus del a rho del phi. And this is going to be in QZ hat direction. So that will give me the final answer for curl A. So we can simplify this, put it together. Because I don't have a z derivative of rho here, this term will disappear, so this rho and 1 over rho will cancel. So for curl A, I can write the following: 1 over rho del AZ del phi minus del A phi del Z, and this is in Q rho hat direction. And as for the second term, I can operate the minus sign, so these will change positions. So I will have a plus del A rho del Z minus del AZ del rho, partial derivative in Q phi hat direction. And for the last term, you can see here this is a rho derivative, so I can't get rid of this one. So it's going to be remaining the same. So this is going to be plus 1 over rho del rho A phi del rho minus del A rho del phi in QZ hat direction. So this is going to be our final answer for the curl of A written in cylindrical coordinates. So we started out with our position vector, take derivatives with respect to rho, phi, and z to get the scale factors. And for the gradient, we have qi hat over hi del qi. And for the divergence, 1 over the product of the scale factors del hj hk ai over del qi. So that's what we have done here. And as for the curl, we take this determinant 1 over h1 h2 h3, h1 q1 hat h2 q2 hat h3 q3 hat partial derivatives and h1 a1 h2 a2 h3 a3. So this gives us our final answer for curl A. So we can make this slightly bigger. This is our final answer that we obtain for the curl operation in cylindrical coordinates.